Hi, welcome back to my channel, and in this video, I'll be talking about things that mathematicians are very conscious about. Like people in the other fields of disciplines, mathematicians have things they are very conscious about. So these things distinguish them to be real mathematicians. Although some mathematicians are not really into being conscious about mathematics stops and whatnots, some of them have actually things they are very conscious about that makes one mathematician be able to distinguish another one of his kind. In this video, I would like to talk 15 things that mathematicians are very conscious about. So this is my opinion. So if you think there could be a lot more, then you can comment down there on the comment section of this video. So again, this is not really for all mathematicians, but for all of these qualities I'll be mentioning, most of them are actually characteristics of mathematicians. Number one, mathematicians use pi instead of 3.14 because pi is never 3.14. That is, say for instance, find the circumference of a circle with radius 5 units. So instead of solving 2 times 5 units times 3.14 to get 31.4 units, mathematicians would answer 10 pi units because again, pi is never 3.14. It is just a mere approximation of the value of pi. In fact, in the systems of real numbers, there are two major subsets of that system. First is the set of rational numbers, and the second is the set of irrational numbers. Pi belongs to the set of irrational numbers. So, irrational numbers are defined to be the numbers with non-terminating values. So if we take pi to be 3.14, then that is a terminating decimal, and so pi could be irrational numbers. But the set of rational numbers and set of irrational numbers have no common intersection. That is, when you intersect the two sets, the resulting set would be empty set, which means that pi is never 3.14. Also, if we take the convention 3.14 for the pi, that means we're actually rounding it off. Well, Samuel Johnson says that rounding numbers are always false, which says that pi could be false if we take 3.14 as the value of pi. That's it. Number 2. Aside from pi, some textbooks use e, the Euler number, to be equal to 2.72, or sometimes they round it off to 3. Again, rounding number is always false. In fact, the Euler number e is an irrational number, so its digits go on forever. Oops, walang forever. Kidding. Anyway, this is approximately over trillion digits of accuracy. So it's non-terminating decimal, and it's very qualified to be called an irrational number. So again, mathematicians, instead of using 2.72 as the value of e, mathematicians use e, just e, and not 2.72 or 3. Number 3. Geometers, when draw an equilateral triangle, prefer this figure instead of using this figure because the equal symbol on every dimension of the triangle is enough to justify that all sides are equal. Although you may see the second figure as equal, like just looking at the figure, mathematicians are not really convinced unless there is an indicator that all sides are equal. That's it. Number 4. Mathematicians are not convinced that this figure is a right triangle. Unless they say this figure, that means there is an indicator that there is an existence of 90 degrees by just looking on like a square symbol on one of the vertices of the triangle. That's it. Number 5. Given equations like x squared plus 4 equals y, when mathematicians aim to solve for x squared in terms of the other variable, let's say you get x squared equals y minus 4, before writing the second equation, mathematicians would use the symbol, which means implies, before writing the second equation. That is, you would have this symbol to indicate that the first equation implies the second equation, instead of just writing it right away. That's it. And note that that can also be represented by the symbol, if and only if, because mathematicians would like to tell that the second equation can also imply the first, and the first can imply the second. That's it. Number 6. When asked why x squared plus 4 equals y implies x squared equals y minus 4, instead of saying transpose 4 to the other side, mathematicians don't use that word. Mathematicians would say they add both sides by negative 4 to arrive this equation. Because the word transpose is actually the word used by linear algebras for matrices, where the entries on the row n are actually now the entries of the column n. That's it. Sometimes, some students might say they did cancellation. That's why they arrive with the equation x squared equals y minus 4. Well, actually, there was no cancellation happen. Although some mathematicians would use the conventional word cancellation, but some of them would think that there was no cancellation happen. So just the word adding both sides by negative 4 is actually the right term to say. That's it. Let's consider another, for example, x plus 6 equals y. To get the result x equals y minus 6, mathematicians simply say they add both sides by negative 6. And the equation like 3x plus 5 equals y, to get the equation x equals y minus 5 all over 3, instead of saying transpose 5 to the other side and cancel 3, mathematicians simply say add both sides by negative 5 and divide after by 3. That's it. Number 7. Given equations like xy equals x, and then some textbooks would say y equals 1, mathematicians don't believe that unless they are convinced that x is not 0. Because the way people would do the cancellation, the conventional use of cancellation is the way division is being done. So if x is 0, that means mathematicians are violating the rule that they can divide anything by 0. So that is the reason why mathematicians don't answer right away that y equals 1 from the implication of the equation xy equals x, because again, we cannot divide anything by 0. That's it. Number 8. When asked for a certain problem like solve for the value of x satisfying the equation x squared plus 5 all over x equals 10, some mathematicians don't answer right away unless the one who questions that provide an additional statement that x is not 0. Although the presence of the statement x is not equal to 0 is not used in solving the value of x in the given expression, it is still pointless for mathematicians solving that certain expression when x could be possible 0. So for many mathematicians, this expression is not enough when there is no additional statement x is not 0. That's it. Number 9. The most common mistakes that most students commit and some mathematicians can notice is that x squared equals y squared does not imply x equals y. Some students would argue that the reason why they get x equals y from x squared equals y squared is that they took the process of taking the square root of both sides. Mathematicians would do this instead. Given x squared equals y squared, mathematicians add both sides by negative y squared so that they'd get x squared minus y squared equals 0. And then mathematicians would factor the left side of the equation, and so it gets x minus y quantities times x plus y equals 0. So we have x equals y or x equals negative y. Therefore, x squared equals y squared would imply that x is equal to plus or minus y. That's it. Number 10. Mathematicians don't rely to any phrase, especially when it is ambiguous, because it might lead to mistake or wrong interpretation. Example, the statement 2 over 3x could mean two things depending on the message of the one who conveys it. It might lead to expressions like this or this. But when reading the mathematical expressions or perhaps statements, mathematicians would read in a manner that as possible can avoid ambiguity. For instance, this mathematical expression is better when read as 2 all over the product of 3 and x. Or better yet, the quotient of 2 and the product of 3 and x. Or 3x. Or this expression is better when read as 2/3 of x. That's it. Number 11. When writing the equation like 3x plus 5 equals 7 over x, mathematicians are very particular on how it is written. The bar line of the fraction 7 over x should be aligned to the equal sign. So it should be written like this instead of this. That's it. Number 12. Mathematicians know that infinity is not a number. Although I happen to see that there are some textbooks who would declare that infinity is a number, but it's actually not. So there is no way we have infinity minus infinity. So it is very wrong to say that infinity minus infinity is 0. We can just leave infinity minus infinity and that's it. Moreover, there is no way infinity can also be a denominator of a number. That's it. Number 13. Some mathematicians know that there is no comparison to the set of complex number to the set of real numbers. Some may think that the set of real number is a subset of the set of complex numbers because a complex number z can be written as x plus iy, where x and y are any real numbers. But mathematicians know that the set of complex number is isomorphic to the cross product of the set of real numbers and another set of real numbers. That means the elements of the set of complex number is of the form this, x, y, where x and y are real numbers. Meaning to say that the reason why there is no comparison between the two sets real numbers and sets of complex number, it's because there is no way to compare a single real number to an ordered pair. That's it. Number 14. Mathematicians know that the square root of a number is not always positive. Example, the square root of 25 is not just 5. The square root of 25 is 5 and negative 5. This is the way we think that the square of 5 is equal to the square of negative 5, which is equal to 25. That's it. Number 15. Some mathematicians don't use Microsoft Word when typesetting equations because they are very particular on how equations are written. And Microsoft, sometimes when writing equations that are too complex form as rational expression, it might lead to the possibility that the equations are distorted. And also, mathematicians are very particular on how the characters on the equations is distinguishable from a normal English alphabet. That is why instead of using Microsoft, mathematicians use a software LaTeX. LaTeX is a high quality typesetting system. It includes features designed for the production of technical and scientific documentation. LaTeX is the de facto standard for the communication and publication of scientific documents. LaTeX is available as free software. So everything that is written mathematically will be typeset on the LaTeX editor. That could be TechWork or Tech Studio, and then the finished product would be in the form of PDF file. So this system is not just for writing document, but can also be as a replacement or alternative for PowerPoint presentation. So if you want to more a lot of things about LaTeX, you can just subscribe to my channel because I'll be uploading soon on how to use the basic LaTeX. So I know there could be a lot more of things that may define a mathematician. So these are my observations. So if you think I miss things about mathematicians, you may comment down there and let everyone know about it. Okay, thank you so much for watching, and please don't forget to subscribe my channel because I still have many contents to upload. Thank you so much. Have a great day to you.